be a Monday question. Okay? So, we're supposed to sketch 5 pi over 6. Probably shouldn't be a problem, because don't you get to have your unit circle in front of you? Alright, so which quadrant does it land in? Second quadrant is like right here, right? And then you do this, and you write 5 pi over 6. Okay? Here, we go to 31. Okay. Alright, we are given that the sine of alpha is 4 over 5. We've got to find the secant. It gives you a hint that we can use sketch a right triangle. We could also use the identities. Okay, so you don't have to do it the way they say. So you guys want to do the right triangle or the identities? Identities. Okay, so let's try one with that. I can do sine and cosine square. I can use that Pythagorean to get the secant, couldn't I? So if we did sine squared plus cosine squared, what does it equal? 1. So we're using the pink signs. We're not following these instructions. What am I going to put in for the sign? 4 over 5. Good. Cosine squared alpha, right, equals 1. Not that it matters. You're not going to be looking at your work. All right, I'll be alpha. All right, what's 4/5 squared? There you go. Thank you for your advice. All right, cosine squared alpha equals, instead of 1, I should write, good. What am I going to do to move the 16 over 25 over? Subtract it, we get 25 minus 16, guys. We get 9. Is that right? Alright, and then how do I undo the square? Square root. Now, technically plus or minus. Here's the part where this is kind of, if we used the triangle, we would have probably only gotten the positive. Okay? So I'm going to stick with the positive. What's the square root of 9? 3 over 5. They didn't tell us a quadrant, and this guy was positive, so I would go with all positives since they didn't tell us, and they told us to use triangle to do it. That's probably why I'd stick with the positive. Alright, how do I get secant from that? Flip it. Okay? Again, we did one with the triangles yesterday, so you could do triangles too. Okay. Alright, we good with 32? Alright, do the next one. We're supposed to find the exact value of the trig function tangent of 150. What am I going to use to do this? What should I have out to use? You should be using your unit circle. So either you look at the unit circle on a pink sheet or you get out your own unit circle. Okay? What is tangent? Sine over cosine. So I need, first of all, the y value for the sine at 150. What is it? 1/2. Alright, what's the cosine at 150? Good. Alright, what happens? Twos cancel, I'm down to negative 1 over square root of 3. What do I have to do? Crash, which was really good. Way too much. Okay. Determine the exact value of the cosine. Okay, this one, look at how awful the wording is, right? They want us to find cosecant of pi. If I had just written it like that, you would know exactly what to do, right? So you really got to make sure that you translate those words into this, okay? So cosecant of pi is right over here, right? Negative 1, 0. What's cosecant of sine? What's sine of pi? 0. So when I flip that, what do I get? 1 and 1. Okay. Okay. What is this one really asking us to do? Yeah, they're asking us to do that. Okay. All right, so 3 pi over 4. value at 3 pi over 4. And the cosine, what does that reduce to? All of these unit circle ones are really good for the Tuesday test. We don't need a calculator. Okay? So the trig that doesn't need a calculator, that would a lot of it would land on the Tuesday test. This one would be on the Tuesday test because I don't want you to use your calculator to figure it out. All right, I'm going to label the graphs just A, B, C, D again, so that way we can talk about them in the context of that. All right. First of all, where does cosine start? 0 or 1? Well, it starts high, right? So based on that fact, it either starts high or it starts low. Which one can we eliminate? Okay, so I know E for sure because E is a sine graph, okay? All the other ones look cosine-ish. Because remember, the amplitude could be high or it could be low, okay? What is the amplitude here? 4. Do you see how the 1s are on there for the amplitude? So the amplitude 1s can go. And then we said that because this is positive, we would start high. So which one starts high ought to be a D? So it's got to be this graph right here. Okay? Again, remember, we didn't make you sketch out the big thing, right? So you just pick the right ones. All right. Big hint, this would be on the non-calculator test. Let's look, without using a calculator. Without using a calculator, we can look at the second day. Okay? All right, so I've got to go to arc sine. So is sine the x values or the y values on the unit circle? The y values, okay. So the y values, I need to look around the entire unit circle, and I need to look for where the y value is equal to negative square root of 3 over 2. Let's go with the radian motion. Okay, so you heard 5 pi over 3, where else? 4 pi over 3, good. All right, we okay with 37? All right, we're back into the wonderful world of logs. It's been since about January, right? God hasn't been good at going back and making sure you keep knowing how to do this. Okay? So, let's refresh our memories. Yeah. On the last one, I'm sorry. Unless you put in 1. Okay. So, both of them are correct, right? My guess is that on the actual test, only one of them is going to be listed. Okay, does that make sense? You only get to pick one. Because it'll probably be more strict multiple choice versus multiple choice. Okay? So that might be what it came from, but both of those are right. So you just know how to do that. Okay? Thank you for asking that question. Alright, let's all go to 38. You're going to need your calculator in front of you. Okay? How do I get the exponent or the x out of the exponent? What do we have to do to both sides? Remember that? That's what you have to do to both sides. Remember, logs are really powerful. Their power comes from being able to take, when I take the log of both sides, that exponent's allowed to travel out front. That's the logs are the only way to solve for a variable in the exponent. Okay? Unless the bases are the same, then we can do it another way. That's really the only way, especially with decimals like that. So now I've got x log of 3.07 equals log of 29. How do I get this to the other side? Where it's a number. You divide it, good. So x equals log of 29 divided by log of 3.07. All right, I want you to try to put that in your calculator. Remember, you can ignore the base part. It's base 10. You don't have to fill in the grade part. I'll give you a minute. I don't know the answer, so I need you to actually figure it out. Okay, 3.002. Which day would this one have to be on the test? This would have to be a Monday problem, right? Because you have to have your calculator to be able to do that. I didn't teach you how to use a log table. Right? I don't think I even used a log table when I was in school. But they exist. Alright, let's go to 39. We're going to solve the equation and check for extraneous solutions. What kind of number am I not allowed to have inside of the logs? Yeah, you're not allowed to put a negative inside of there. Okay, so if I get a negative number or I put something in there that makes it negative, I can't use that number. Okay? Alright. So right now, I've got to get this thing here out of the log. Okay? Remember when we have one log on one side, what do we use? Remember the name for it? We do this thing. We're going to use the log loop. You guys are really good at it. It's been a long time since we used it, right? So, we're going to use the log loop. So I'm going to go 4 to what power? Second equals 3x plus 10. Alright? Alright, what's 4 squared? 16. Good. Equals 3x plus 10. Alright, what am I going to do now? What do you guess? And x equals 2. Okay. Is 2 going to be okay if I put it back in there? Yeah, I'm getting a positive, so we're good. So 2 is my final answer. Okay. And if you need to, right off to the side, we did the log loop. That'll probably give you some context. You have to go back and try this. Okay. The log ones, sequence and series ones, those you guys need to, I know we just finished trig, so it's on your mind. Those two are kind of far removed from. You need to practice those a few times this weekend. Okay? Preferably on Saturday, so you can spend Sunday out from home, right? It is another tip. Okay. Alright? But you can't tell them, hey, I've got a final. Give her a kiss and make her breakfast. I'm going to be grading papers on those next. Because I'm down to the last minute on it now, so Saturday is already booked. So. Okay. Just give everybody an A. That makes it easier for me. Thanks. That's my Mother's Day gift for you. Alright. Alright. 2 ways that we can do this one. Okay? And I'm going to show you both ways because this one could appear actually on either day. Okay? It says that we actually have to go through the evaluation, so my guess is it's probably better on the calculator one. Okay, but let's do it non-calculator first. Okay? It is entirely possible to say, when they say change base, remember we do the log of the big number divided by the log of the base. That could be an answer. But it really didn't evaluate it, right? So what I want you to do is now use your calculator, and remember change of base is kind of a dead thing there. Okay? Because our calculators are so much more sophisticated than they used to be. Right? You can literally type in, but make sure in that base number you put a 5. And then give you the decimal point. It could be either way. I'm probably, once I actually get the final written, I may put out a set, well, I'll send out an email that says, hey, there's some extra hints out there for the test, and I'll put some hints up on my too on what's going to be on what the problems on what days. Okay? But that probably later on today, because like I said, I haven't finished writing the final. I have to rearrange things. All right, what do we get? 544. Okay, good. All right. Use the properties of logarithms to expand the expression. This would be a more of a non-calculator thing. So this one could go on day 2. Right? So the first thing I'm looking at is what do we turn division into? Subtraction. Remember, it makes the horizontal line just like subtraction makes the horizontal line, right? So log base 7 of x cubed minus log base 7 of x to the 1/4. What's the other thing I need to do? Actually, look at your answers. Do I need to do the other things? I get this one, don't I? It's the only subtraction. So be careful. Don't fall into these two traps right there, right? Okay? Alright, so but I should really, in theory, I should be showing all my work on my homework, right? I should be putting that up front. So log base, 3 log base 7 of x minus 1/4 log base 7 of x. Don't freak out, there's a fraction. Any calculation. Okay. Alright, we have to write it in logarithmic form. This means we're going to do a log loop again. Okay? So but we're doing the opposite log loop, right? The other one we did, we went into, we got rid of the log, now we're getting it back into exponential. Or sorry, now we're getting it back to the log. Alright, so what's the base of my log? 3. So that one goes, right? Alright, so log base 3 of what? 81 equals log base 3 of 81 equals right there. Where did the 64? Look at the answers. That's a really bad question. There's only one that has an 81 in it. Oh, wait. We could get it to, oh no, it's not going to, we just want to show the loop. It's not going to, we're not going to do the canceling thing. So yeah, that's a really dummy multiple choice. Alright, gotta find the exact value. Here's the other one I was just thinking about the last one. I want this number and the base number to be the same on this one. Okay? So remember it has to be same base, same level thing. What's another name for 64 as a base of 4? 4 to the third. Okay? You should know that without a calculator. Okay? I can't do anything when it's in the denominator. How do I get it upstairs? I can't reciprocate. What do I do to the exponent? What do we do to the exponent to get it to move? What's that mechanism process to move again? Well, if I saw something like this, what would I do with it? Not flip it, but what? Gotta make it happy, don't I? Make it happy, we move it downstairs and take the negative off. Can't I do the same thing here to reverse the process? Make it negative. So remember the exponent thing is we have to make it negative. We have to get away from this. Think about this too, because this is where it drove Mr. Levis nuts this year in AB. He said they don't know how to do logs. I'm like, they know how to do logs. They were just fine last year. It's good, but we don't do them again until like next January. So you get it for a little bit in January, you take a year off, and we do it again. So the log thing is important. Okay, that we understand it. All right. So we got. Oh wait, what happens with these guys then? They cancel. We're left with -3. I think we only got one left, right? All right. Identify the log, or identify the value of log. So similar to what we just did. Okay. What is another name for a square root? What do I do with that? You're making an exponent? What would the exponent be? 1/2, or you die. We do almost daily. Okay. What happens with log base 4 of 4? Cancel my answer. Okay. You need to go back. Take the log section, take the sequence of series sections of this study guide, and try them like 4 or 5 times. Okay? Because it's been a long time, especially on the logs, since we've seen stuff. Okay? Alright. The rest of the period is yours to study. To get stamped, seniors, I have to see stamping by Tuesday. Okay? Everybody else, all your stamps are due by the 25th.